Okay. So when you watch the YouTube videos, for example, go to YouTube. If you happen to watch something like this, which is half an hour or 1 hour video, I think I already told you. Like, okay, it's ad actually.
2.8 lakhs in 2022. That's it.
This article's video will look at
Sorry, it's in Hindi anyway. What you can do is, you can just, if you feel it very slow, for example, I'll play it from here.
यहाँ पर मैं एक चीज और कर देता हूँ, सेव बटन को स्क्रॉल करता हूँ,
It's
यहाँ पर जो है वैल्यू चेंज हो जाएगी.
you can just increase the speed. So you can make it any speed that is audible to you, that you can understand. So that if 1 hour content, you can finish it in half an hour. It will greatly improve actually. So let's see this. Sometimes it's not audible, right? So we can reduce it. In some videos it will be very very slow actually, like my videos which you are seeing, right, will be very very slow, but there is no option to play fast actually. What you can do is you can install VLC player actually. VLC player is there, right? So you can install VLC player, play the video in there you have the option to play fast actually. So lot of videos like technical videos, it will be very very slow, like 2 hours they'll pull it. You can just reduce to half and then play, and it will help for your development actually. So before getting into pointer, one thing I missed out actually. So we didn't see the structures. We have the structure, right? We didn't see how it represented in memory actually. So let's say student 1. So it's a integer. Maybe I'll give all. So this is the maximum value you can put it in, right? It's Sandhya, you know this, right? So, and because it's 4 byte, so 1 byte is FF 2, 3, 4. Okay. So and then double. Just compare it. So let's see this in memory. It's also one kind of data type, right? So you need to get the address of this one. So Ampersand is Steve. So here you have. So let's see what happens. So the 1 byte, right? This is 1 byte actually. So it got changed, this one, and let's see what happened for this one. So I don't know why it is. This is 1 byte, right? Yeah. So it should be continuous, right? It's not continuous. Okay, let's see why it's that one. So the next, so all become FFFF. Okay. And then it is it changes. So only thing is it should be continuous, but it skipped the this many like 3 bytes extra, like to make it a 4 byte actually. So actually they have something called memory alignment, actually inbuilt memory alignment. So normally when you have a structure like this, for the if you to increase the speed of your process, normally they'll have this memory alignment. So when they what is this say x60, so it is easy for the processor to access which is properly aligned in the count of 4 or 8 actually, so that it can directly read that memory. If it is not aligned, if it is aligned here, somewhere here, so some additional instructions, assembly instruction need to be written, that will take some time. So for improving the process, it will be like aligning the memory, but still you can there are some statements that you can say you don't align for me actually, so you just put it in a continuous memory actually. So you understood, right? So can you tell me what will be the size of this one? What is the size of this? One is 4, this is 8, and this is 4, right? So how much it can? 16, right? So 16. But when you see the size of the student, it will, let's see, let's print it. Okay, I'll print it here. Let's see the size of this one. It says 16 only. Okay, so I thought like it will say like what is the student one? So it is 1 byte, right? So this is 4 byte, right? 4 and 8. So how much it comes? How much?
13.
13. So I thought like 13 it should come, but okay, 16. How to get the exact size? Let me see. Let me see. Instead of that variable, we'll put this one. Okay. Both are coming 16. Okay. So there are some, as I said, there are some statements which will align you properly. Maybe I will not tell you that why. What is the statement? Actually, I use it in my project. Actually. So for the proper alignment of the structure. So if you have the proper inbuilt alignment, like if you have all int, then it will be proper. It will be proper actually. So let's see for student 2. Student 2. I will assign it here. Okay. Let me make it public. So one is n. Okay. So we have a static variable, right? So can we do this like this? We'll see. So let's see what happens. It failed actually. So you cannot access this static variable, so like this. So static variable, okay, I'll let's not go into that one. So the way to access the static variable is like this. So let's build it. Sorry, actually not even like this actually. So it is the class name. Okay, so we have to declare the outside of the. Okay, we'll do it outside of this. Oh, it got succeeded. So, can we'll just change this. Can we do like this? Okay, it allows me. So they are like different category of variable. They are not a member variable actually. So that you have to keep in mind. But the purpose is I want to show you the structure of memory for the student actually. So let's debug this one. Let's see for student 2. Let's see what happens. It didn't change anyway. Why? Okay, oh, it's anywhere. Okay. So here also the same thing, and we'll see the changes here. Well, let's see what happens here actually. So there's no change actually. This means the static variable are not part of the that structure actually. So they are outside of the structure, and there is a inbuilt alignment for the increase the performance of your process. So that's why they are not aligning in sequence. They are just leaving in multiples of 4 actually. So that your processor, whenever it fetches the address of the variable, it can become easy directly. You can the bus, right? The processor bus. You can directly get the address without any difficulty. So that's why they are making this alignment. So let's there are certain changes in properties, like how to avoid these things. So that's not a big problem actually. So I said about static variable. What is a static variable? Like a global variable, but is accessible within that function, yeah, within that block. So I told only the static variable. I didn't teach about the member static variable, means a static member variable or static member functionality. So maybe later on you can go through. And static variable mostly used for singleton. If you just study a singleton pattern, one small class, that is easy only actually. Singleton is a very easy design. There they will be using static. Then you will understand the purpose of static member variable and static member function. Okay. And what is constant? Cannot be changed. Okay. So I didn't tell you what is the use of that one actually. So I will tell you that one also. Earlier we were using something hash defined pi, right? So 3.14. Okay. So wherever I want to use this value, I can just replace with the pi. So maybe double d where 1 or something where 4 equal to pi into some value actually something 5 or something. So what happens is before preprocessor, before even compiling, it will just replace, the preprocessor will just replace this one here actually. So wherever you try to use this pi, it will replace this value over there. So that is what hash define. So let's see the constant. Constant int, no, not int, double d maybe pi equal to 3.14. So you are using hash define pi is same as like you are using a pi variable. Only thing, there is no memory for this. It's a preprocessor. That nothing to do with your process memory. It will just replace wherever you use it. But here it is a memory actually. So you have a memory space allocated for that thing. So wherever you use this one d pi, so it won't replace. So it will just take this memory, whatever the value is there in this memory 3.4, and multiply by 5 and replace it here. So some people, instead of going for hash define, they will use like this actually, a fixed value. So for example, epsilon is a fixed value, some mathematical constants are there, right? So fixed value. So for those things where it will never change actually. And we also use concept, by accident they should not change the pi actually. You are passing this variable to some pointer or somewhere in a very huge program, and there you try to manipulate something, accidentally you change, means just you put constant, it will report an error that you cannot change. So that's what. So I have one question. So you are declaring an array of double, okay. Say there are some few elements are there actually. Okay. So the starting address of this one is, maybe I will write it somewhere here itself. I will write it. So 0x00145 like R2 something like this. So okay, it's a double. Okay, double D or some val of okay. Can you tell me the address of this location? The first element, second element, third element. So address of the starting address of the third element. 144, right? Okay, you said 144. Right. So double size is 8 bytes. 58, right? 158, right? So we'll see. 0x00 158. Pawan said 144, right? Okay. So a double has 8 bytes, right? So you can divide this into 8 blocks actually. So 8 blocks. So the first block address is 142. Okay. Wow. So since there are 8 blocks, the address of this block is you just add 8 actually. So 148 into 8, 150, right? So 150, 0x00 150. So you have another 8 blocks here actually. So 8 bytes here. So you just add one more 8 bytes, you will become 158. You understood, Pawan?
Yes.
Okay, so it's a count of byte actually. So how many bytes? It's good actually. So we will go through pointer variable method. So first declaration. Some precaution also I will teach you, where many people miss that one actually. Where is it? Oh, generation. Okay, so okay, so So how to declare a pointer? Okay, pointer variable. Wait, don't write anything. So it's okay, right? It's not this way actually. So I'll tell you the reason why I typed this one. Okay, so pointers are like you already know. We have a type actually, int, and then followed by star. So if it is a char, actually let's say char followed by star and then the variable. So always begin with p actually. That will clearly tell you it's a pointer actually. So in some of the project in the cat project, like it is very difficult to find whether it's a pointer or variable actually. So I have faced this difficulty in cat project actually. So that's why it is better always follow this one p and then char ch. So actually okay, we'll do like some pointer variable one. Okay. So why you need to declare char? Why can't the compiler or C++ provide a data type called pointer? So instead like this you can just have a data type like pointer, right? So I'll tell you the reason for that one. So you for declaring the pointer you just use like this. So now I'll declare a pointer for int. Okay, int star p n pointer var1. Okay, let's so this becomes a pointer variable. Okay, this becomes a pointer variable. You can also declare like this also. So maybe float, you can put a star near to that variable. So p f so you can declare automatically. It went this side actually. So if you want to declare one more thing, you can say star p f pointer var2. Okay, so it automatically leaves a space actually. So you can also combine it. So this is also a pointer, this is also a pointer. Okay, if you don't like on that day we saw that, right? So if you don't use the star here, if you don't use the star, what will happen? What type? Normally it will become a float actually. So what happens is it will consider this one as pointer, float pointer. It will take this one as a float actually. So that's why it is either here or just adjacent to that variable. So that way. Now one important thing. Let's see the size of it. Okay, size I will use wprintf. Okay, okay. WC, okay, I'll use. Okay, I'll just print one more thing. I'll just remove for to show you what happens here for this. So what happened?
Same variable.
Same
Float,
variable.
yeah. Instead of n, you have to give f. So I'll do one by one. Okay, let's see. I will just execute this line. Let's see what is the pointer of character, right? It's 8. Okay, let's see the size of this pointer. It's 8. Let's see the size of this pointer. that is also 8. Okay, so let's see the pointer of this one. Assuming this is a pointer, we'll see this one. It's just 4 actually. So it seems that this is just a normal variable. So from the size itself, you will know it's a pointer, it's a variable. So what is the point here is for char it is 1 byte, for int 4 byte, for float it's 4 byte, for long it is 8 byte. So pointers, like, they have always 8 bytes fixed, that's it, no change. Okay, so all pointers same size. So you will understand more on this one. Okay, so now what I will do is I will just change this to XCD. Let's see what happens. I'll declare this one star here. Let's see if it comes 8 or something else. So it's all 4. So 32-bit process, right? So you understand, like, so 32-bit process means it's like 4 bytes. The bus will be like there will be 4 bytes each to access it's a 32-bit process actually. So for a 64-bit process, there will be 8 bytes actually. So the maximum the bus size to access the addresses will be 8 bytes actually. So that's what it depends upon the process. What is this on the platform actually? Based upon the platform, you will have to the size will change. So, but whatever the platform, it is fixed 8 or 4. So okay, so I will be just showing you the x64 itself. So next what? Okay, so the first thing, okay, yesterday I was saying, right, when I was showing you the memory, various type of functions to allocate memory, right? Not here. So I was telling you about this memory allocation, right? I told you I just told you one statement that these things are like a hell, right? You remember? So once if you learn, it's not a hell. But problem is, most of the people, not most of them, some of the people, they are not aware in detail about the pointers. They write code, and it happens that you will be debugging their code, or they might have left the organization. You will be debugging those code. In that case, it becomes a hell for you. So someone's code who don't understand the pointers fully, and they try to write some program and try to do some, when it comes to you, like for you to build a bug fix or something, where those people have left the organization, then it becomes a hell. So it is better you always keep aware of this pointer. So to avoid such things, what you have to do is, so that your program should not be hell for others actually. So first thing, you must initialize. Okay, initialize it null. Okay, first thing, always initialize a null, or you can initialize a valid address. Okay, I will tell you about that. So and then whenever you use a pointer, assume that your pointer is allocated to some memory, and whenever you use a pointer, you just check whether the pointer is or any of the pointers. So is not null. not null, sorry, not null, and do whatever you wanted to do. Or you just, if it is null, you do whatever you wanted to do. So this condition always should be there. It's not like wherever you use this pointer, only in the beginning or somewhere whenever you start to use. Thing is, most of the time this conditional check will cost you actually. It will take time to do process. It will increase the time speed of means it will delay your program actually. So always so it is necessary that you need to check actually. So okay, so you understood, right? First initialize with any address, valid address or null. If it is not, you don't have the valid address, immediately you don't get it, initialize with null. Then next thing, whenever you are trying to use, whenever you are trying to in any function, first before using you just check whether it is allocated or not allocated. So condition check should be there. Okay. Then the third thing is, after you finish with the pointer, you just initialize with null again. So in case if it is while loop, this will be helpful. If you are repeating the process in a while loop, trying to use the memory pointers, so sometimes you will be if you don't reinitialize it with null or some other valid address. So when I say null, like some valid address, or if you don't get it immediately, just null. So what happens is in the while loop, you will end up in accessing some wrong data actually. So these three things you have to follow. This one at present it is not pointing to any memory. So for that's why I just showed you. You have to do these things. So because many times when we handle that in Hello Core service, we would have just missed this condition check, and suddenly our QC or sometimes even customer will raise it, your program crashed actually. So and then immediately what we'll do, we'll first look for these pointers and check whether we are adding any conditions to check whether we are validating that pointer. So sometimes it fixes that problem actually. So that is the thing. So okay, I don't have to display the diagram for pointers. So okay, okay. Let me ask you one more. So all pointers are same size, okay, 8 byte or 4 bytes, okay. So why do you have this type actually? Instead they can go for this pointer, right? Something like you declare one pointer and variable you can have, but I'll answer it later. For that reason I just type like this, okay, but it's not a valid one. So we don't have it like this actually. For one particular reason I will tell you actually. So now next thing is assigning to an address. Like you can allocate a memory and assign it, or you can allocate, you can point it to an existing variable. So first I will show you how to point it to an existing variable and tell you. So for that I just need to, so it's a characters pointer, right? So I'll allocate, so following, right? Okay. So character ch okay, I will not initialize for now, okay. Okay, then in where float. So I just declare some variable. So you know in memory there will be a space, a box will be created for this for these variables in the stack memory. So pointer always take the value of address. right? You know that one. So, and you know how to get the address of the variable, right? How? Ampersand. Yeah, good. So, just I'll take this equal to ampersand of this requires address, and we get the address using ampersand. Okay. So, when we assign an address to a pointer, it's called referencing. I don't know the spelling. Correct, right? Okay, whatever. So referencing. So when we assign address to a pointer, we are referencing a pointer. Okay. Same way this one. Sorry. So whatever you study about pointers, don't forget this: initialization, condition check, and then lastly, like whether reinitializing with null. Don't in your entire life, don't forget it actually, because someone else will say the heat. Okay. So one more thing I forgot to say. So this is one type. This is one type, similar to another types like a char, int, bool or whatever it is. This is the variable. Keep that in mind. Okay. So since it is a star, the size will be always 8 bytes or 4 bytes. Okay. And whatever you studied about the variables, right? That also applies here, with some additional new things I will tell you. So okay. So just see this one as a pointer. Okay. I mean just a normal variable. And you know the size also, it's 8 bytes. Okay, so can we assign a pointer to the same variable? Can we assign to a pointer to the same variable?
Sir.
Yes. Yeah. So we'll do that one. Okay. Okay. Now we are referencing it actually. So next is apart from variables, what are you know about variables? One new thing, like referencing is one thing. You can assign an address. You can dereference. That's called dereference. Suppose I don't know how to explain. Okay, I will put it here this way. Equal. I will assign this one with some value. Okay, maybe 60 value. Then I will no. Okay, so apart from like a special type, like for a pointer, this is the additional thing apart from the normal variable, that is dereference. You can use star pointer variable. So what it means is you are getting the value. What?
Variable.
Yeah, value of the location where this pointer is pointing to actually. So that's what is the meaning actually. Not a way. Okay, what you said is correct. Whatever this pointer is pointing to. So now where it is pointing, this this variable, this pointer where it is pointing. See there, this pointer where it is pointing. Yes. So ch where 1. So dereferencing is wherever it points to get the address of, get the value of that location, address location. So for example, I can print, okay, I'll use printf, w printf. So maybe it's a char, right? So C actually. Let's see. So similarly for other things, okay, what is it saying? Using uninitialized memory, okay, that we will see it later. So one is int, right? So int, either you can use u, unsigned int or d. So when you declare unsigned int, you can use u actually. So I'll just change this one, pointer to integer, okay. So this one is float, right? So float, and this one is also float, okay. So I'll change it. Oh, 2. Okay. Okay, for what I'll do is you can change the value of this particular variable by assigning, right? So you can, that you already know, you just change it here, you type some value, that's it, you are assigning this value. Through pointer, how will you change is like dereference, you dereference it, okay, then you just change it to 65. So I will explain you in blocks, it will become very clear actually. So you dereference this. Dereferencing is just taking that that value, actually value of the location where it is pointing to. So it's a int, right? So 0x ff. So 4 bytes. So all f. So same way this one. Pointer, it's a float, right? So some point okay. So okay, let's debug this one, okay. Okay, so let's see. I said you just look this as one particular variable, okay. So I'll just here we need to give the address, right? So this itself is it contains an address actually. So it contains an address. Also it will like this itself is in one particular address space, right? So suppose 1 minute. No, actually, so I should give. To print an address, what I have to give ampersand, right? So okay, so let's see what happens. This variable, this pointer variable is declared, it has like one memory, right, one block of memory. Let's see when I do this null what happens. So 8 bytes all got initialized with 0, right? So same way here, this one. Let's see. So this also got initialized with null. Same way this one also. So that means this is a pointer which is pointing to nowhere. Null pointer actually. This is called null pointer. So this also both the things like yes. Actually this one also we initialize, it shows here actually, it's a nearby actually. So that's one thing. So everything is got allocated nearby. So here is if you just browse it, you can see like this is the char, this is the int, this is the to float, here is float and here is float. So and you know the size of the pointer. So all are 8. Now let's see, we'll keep this one. So this is the char, int and float, right? So everything we can see it here. Like now I am assigning a address of the proper variable actually. A variable is already allocated in the stack, right? So I am just pointing it to that particular variable. Let's see what happened in the pointer. So first of all, I will just print that, like we'll see the address of this one in memory 2. So okay, so this is the address. So character, right? This is the character. So this is the address. So let's see, this value gets copied here. Okay, you understood what I am doing? So let's come back to 1. So here it should get filled with that address of this one. So whatever here this value is, it should get filled. Let's see what happened. No, initialize it. Sorry. See 00007260 F8 F4, right? 00007260 F8, right? So it means now this pointer is pointing to this variable, and this variable is here. So this variable is here. Same way, let's see this n variable. Okay, I didn't initialize, that's why it is CCC. So and here it should change, and the address is like this is the int, right? 4 byte. So it is 00007260 EF FFB14. Okay, well, let's see what happens here. So BFB14 is the same value actually in reverse. So it's a FB14, right? So the same thing. So FB14. So it just store it in a reverse order. So that is why it is 8 bits. So all pointers in 64-bit, it's a 8 bit. So you need to store this address, the address of where you are using your variable. So same way, let's see what is the address for this one. This is the float, right? So so it here also changed 0000, where it never updated, it remained like unhighlighted, right? So others was changed, so that got highlighted with red color. So okay, next one is here. So here also the same. So whatever that float is, the address of the float. Okay, now we know like all pointers are now initialized with this address, proper address. Now we will this is called referencing. Now we will dereference. By dereferencing, we assign the value to the location where it is pointing to. Okay, so this is pointing to a character. So let's come back to, let's see if there is any other thing. I think it should be within this one. Let's see, or let's not take risk actually. So what is the address? FA4, right? And what is this one address? FA4. It's somewhere different location, right? Okay, no problem. So let's first check this one. So okay, now we are dereferencing. I'll just press F10 and see what happens. So it is updating here actually. So this location, that is the 1 byte memory which is at this location, and the pointer is this one. Using the pointer, we are not changing the pointer, we are changing the value of the pointer. So at this location, that is called dereferencing, that we use star. So same way we will check for integer. Let's see what happens when I try to do this. So all got changed here actually. So the original location where it is pointing to. Okay. So same way I will just use. So it changes this one. So float is 4 byte, right? So it's changing the 4 byte value. But it's not in order. Actually, it maybe it's it uses the exponent. Actually, they have some exponent calculations. That way they use it. Now the same pointer is pointing. Sorry. Actually, if you see this one and this one, it is pointing to the same location, right? So let's see. So these two values should be the same, right? So in the pointer. So let's see this pointer. So EBFB, right? So here also 34FB So same thing. So two pointers pointing to the same location. So let's see what happens now in memory 2. In memory 2, where is memory 2? Okay, memory 2. So this is the memory 2. So first it got changed to 324.08. Let's see, we are using the second pointer and just changing the value to a different value. It will update the same location. So two pointers pointing to same location. So this is nothing but just printing actually. So if you print, it will print. So now it will print actually. So why -1? Because it's an unsigned int. It's an unsigned int actually. So if you want to print exactly that maximum value, you have to use a signed you have to use unsigned int here actually. So that's why it is showing -1 here. Okay, so it is printing all these values, right? One is A and FFFF and this values actually. So one is referencing and then another is dereferencing. Okay, so Reference means like you store the address actually. You are pointing actually. So that is referencing. We studied about reference, right? That reference is completely different. So don't mingle that. That is name alias name, right? Or alias name. So that is a completely different. Here this pointer referencing is you are pointing it to some location. So and this one is dereferencing. You are just getting the value where it is pointing to. So now what we do is I will just finish this one. We will take a block. We'll draw the block diagram for this. Okay. One more thing also. I said like if you are not initializing with any variable, you have to assign it null, right? Suppose if you have declared this one on top, if you have declared this one on top, we can just assign it here itself, like something what you do here. So at the time of declaration also, we will comment this one. So you can also do like this. Either valid location or you can just leave it with later on also you can either you can assign it null or you can assign it here itself at the time of declaration. So both are same. Like here it will be address will be null, but here it will be address will be a valid allocated memory. So for now I will comment this one. I will just uncomment this. Sorry. Let's draw the block diagram for this. For now I will I will just remove this one. Just I will keep one thing. Okay. So even pointers are declared allocated memory, means the pointer variable is also in stack memory, right? You understood, right? It's in stack memory. Okay. So all are whatever you declare here, it will be in stack memory. Okay. Maybe okay. So maybe I will just draw the diagram for char and int. Okay. Remaining things I will just. Okay, I think I missed something. Okay, here should be char, right? CHER CH1. Okay. No. Okay. So I will just draw the block diagram for char and int. Okay, I will not just repeat the same thing for float. You just assume it is there. And char is like as usual 1 byte. Okay, and int is Okay, one more thing. If you have a very important task, right? Very important task. If there is any task like request from HR, you just keep it aside everything and do what HR is saying actually. So that is even much more important task for you actually. So suppose for example she is asking you some proof, some detail, you just tell Prakash, Rajesh, your boss, you just tell them I am just preparing for tax, or I am just preparing the document, HR related thing. You just tell them and do that job actually. So otherwise already she is in like she is the only person handling HR, accounts, everything she is doing actually. So you just do her work first and then come back to your work actually. So okay, so care, you have care here. We will declare it small. I'll draw it very small actually. Okay. One and int. And pointer actually. So it will. I am declaring the pointer. So it's a constant 8 byte, right? So fixed size. So this is a pointer, and this is another int pointer. Okay. So these two things. So now it will print the size of the pointer. So it is 8 bytes here and it's 8 bytes here. So now what I am doing, I am assigning the address. So here it's not initialized, right? So assign that address is 0x some 000 0 or 10 like that actually. So and this one is 0x00014 something like that. So and this will be like somewhere 0x0018 or somewhere 20 something like this, and this will be like 28 0x0028. So this is the address. So we are storing in this pointer variable with an address of this character variable, right? So what it does is the address of this one is 10. So it will assign this one here is 0x00010. That's it. Okay. So and then the same thing for int actually. So int actually we are assigning the address, and here it will be 0x0014. Okay. So and then what you are doing is this is what you did referencing. So whenever you actually have to put one more zero I think. Okay. So okay. And now you just assign some address, you are referencing it. So what it means, it will be like this. So we are pointing to this one. So this one is pointing to where? It is pointing to here. And this one is pointing to here. Okay, so means this pointer is pointing to here, this particular location, and this pointer is pointing to this particular location. Okay. Now that is what we did it now by referencing. Now what we are doing is we are dereferencing and assigning a value. So I will come back again here. So I have a question for you actually. So you have a pointer variable. Okay, you have a pointer variable. Maybe okay here. What is how to print the address of the pointer variable?
name.
Mm.
CH pointer variable.
That will print the value of.
Address.
I want the address of the pointer.
Ampersand
Ampersand.
PF pointer where
Where? What?
ampersand PF pointer where to.
Yes, exactly. You understood what? You also said correctly actually. Pointer itself is one type of variable. Okay, that's what I'm trying to say. So this itself is one variable. If you want to get the address, I said ampersand, right? That's all. It acts as a normal variable only. With additional, you can have a dereferencing actually. So okay, what you said, we want to print the address. So I will just it's a x. I'll put x. So it's a fixed site. So we just want to print the address. We just what you have to do? Tell me again. Ampersand. Okay. This is just one thing. Okay. So what is? So I want to print the value of the pointer.
Start.
No, I am saying not a value of the pointer which is pointing to, but just a value of the pointer variable.
Just a PF pointer P where to.
Just a value, right? It's. I said like you have to understand one thing. This is also a variable. It's just a variable. To print a value, just use the name, right? That's what you have to understand that one. You want to get the address of any variable, ampersand. You want to get the address of a pointer, just ampersand. You want to get the value of the any variable, use the name. So you want the address of the any value of the pointer. No. Value of the pointer.
Variable.
Exactly. So it will give the content of this pointer. Okay. You want something outside, you just ampersand. Something inside, you just use the name. Okay. So that is also another address, kind of address, right? So that's why I will use X and just remove this. Okay. Now I want to print the value where it is pointing to. Yes, right? Dereferencing. So three things. In a normal variable, you have these two things, right? So ampersand and but in pointer, one addition thing is star. It's a dereferencing. He calls so it is a character, right? So so this will tell me that okay, I don't have to scroll up. This itself will tell me that okay, it's a character, so I can just check. So the naming convention will help you write a program very easily. It will be convenient. So by seeing the pointer, now it is growing, right? I don't know, like if I type some other name, I don't know what type it is. I have to go and see here actually. That is that will take some time. So and what is this type? N, right? So N, not N actually, percentage D. So keep this in mind actually. So this also this behavior is same with the normal thing. Additionally, you can dereference, and also you have to reference. So pointer should always point to a valid block of memory, right? So apart from other things, like normal variable, you cannot actually you can do it, but let's not go into that one. You cannot do it, okay? And referencing also, you will not do it actually with a normal variable. Only with the pointer you will just assign. So same way you will dereference, it will use the star. Okay. So you keep in mind, pointer is sum to a normal variable but with reference and then this dereference. Two things. So this now you just like we have assigned the proper variable, means we have assigned with the proper location, address location. Here it assigns. So when we dereference this with 65, what it will do is it will see the location. Since star is there, wherever it is pointing to, it is pointing to here, here. Okay, change it here. So you change it. 65. Now the second one is, so it's a dereferencing. So wherever this value, this pointer is pointing to, you just assign the value over there. So this pointer is pointing to this location and you change it here to 0x ff. Okay, so what is this one? Okay, and the rest of the thing will just so as soon as you finish it, you just assign this one with null. That's what the last thing. So both the thing you have to assign with null. So that you don't have to get into some trouble actually. So accidentally you will do some mistake and it will change it everything. So it's fine, right? Pointer, you just keep this in mind, okay? Pointer itself has one address, so you can just use like this. And pointer has a value, you can use like this. To assign a value, we use referencing thing. That is, address of some variable will assign it a value. To get the value of that particular location, you just dereference star. Okay. So next is then pointer to variable, pointer initially, pointer check deletion. Okay, reference and pointer referencing and dereference. Okay, next is we will see pointer in a function, passing as a parameter, right? So we'll write a function, pass a pointer as a parameter. Okay. Maybe are we recording? We'll stop the recording. Very important, right?